Alright, this is the second video for projectile motion in 2 dimension this time. Okay, so in this one we will see the last video we saw when we threw an object vertically upwards, and then when it came down to the same height vertically downwards, and we saw how did we find different values for the height, the velocity and everything, right? Now this one we will see what happens when we throw something horizontally, right? Maybe from the surface of an object, or maybe you just throw something horizontally in a straight line. What happens to the motion of that object? So the previous one was you threw something vertically and it just went up and came back to the same height vertically. This one you are throwing horizontally, maybe with a velocity of say 20 meters per second, just a straight horizontal velocity, and you have not given any vertical velocity initially, so which is 0 meters per second. Okay, now when you throw this object, you see that the object moves. Even though you have given just horizontal velocity, it moves like this. Before it hits the ground, it moves a certain horizontal distance. Of course it has moved a horizontal distance, that is, it has gone up to this part. This is the horizontal distance, and it has also fallen through a vertical height S. So even though you did not give a vertical velocity, you did not push it down or anything, it still had a vertical motion downwards. It kept on moving vertically. Now the question might ask you, what is the value of this one, what is the value of this one, and many other things. So what are the informations we knew? That when it is, there is no upward motion here, right? In the previous example we had the velocity acting in the upward direction, the acceleration acting in the downward direction, but here it's just downward, nothing in the upward direction, and one is the horizontal velocity in the sidewise direction. Now keep it in mind, when something moves horizontally, there is no force in the horizontal direction. Once you have moved it from here, and when it is at this point, or when it is at this point, or at this point, or at this point, the horizontal velocity does not change because there is no acceleration horizontally. Horizontally, the acceleration remains 0 because no one is giving any force on the object. But as it moves vertically, the weight of the object keeps on acting, right? At all points there is a resultant force in the downward direction, and if there is a resultant force, there is an acceleration in the downward direction. So horizontal acceleration is 0, vertical acceleration is 9.81 meters per second square. Now in the previous example we were talking about taking it as negative or positive. Here we will only take it as positive. Why? Because there is nothing in the upward direction. So anything moving downward, let's take it as positive. It makes things simple. Because there is no upward motion, there is no question of being positive or negative here. The only direction is downward. The ball is having an acceleration in downward direction, so we are taking it as 9.81 as plus. Okay, so now let's see how do we find out the values that we need. Okay, so initially, say for example, you are given with the value of x as 1 meter, okay, and you are given the velocity as 20 meters per second. So how long does it take for the object to travel from here to here? We know the horizontal velocity remains constant because horizontally the acceleration is 0. The question is, why does the acceleration remain 0? Because horizontally there is no force acting on it. Once you have released it, there is no force acting on it, and we know from Newton's second law, resultant force and acceleration are directly proportional. If there is no force, there is no acceleration. It should be 0. Okay, so now you have to find the time taken to reach from here to here. So we can use the formula v square equals to u square plus 2as. The problem with this one is we don't know the value of v. Okay, horizontal velocity, here there is no change in velocity, right? So just before hitting the ground or after hitting the velocity, that becomes the same as this one. Okay, so we can't use this equation. We won't go for this one, and we don't know the velocity just after hitting the ground, so it's better not to go for this one, and acceleration is 0. The equation we will be using is this one, ut plus half at square. So what is the horizontal distance it has traveled? 1 meter. What was the initial horizontal velocity? 20. We need to find the time. What is the value of a? Horizontal acceleration is 0. If acceleration is 0, this entire part becomes 0, right? So t becomes 1 by 20, which is 0.05 seconds, right? So it takes 0.05 seconds to travel from here to here. Alright, fine. I think we should just increase the distance a little so the time comes a little larger. Let's take this distance as 10 meter. Okay, instead of 1, let's take it as 10 meter. Then the time will be 0.5 seconds. Okay, so the distance is 10 and the time comes 0.5. All right, now if you find out this time 0.5 seconds, that means the object has taken 0.5 seconds to travel from this point to this point horizontally, right? So when it was moving horizontally, at the same time it was also falling down. It's not that the object was only moving horizontally and then it fell down suddenly. When it was moving horizontally, it was also moving vertically downwards. So there were two types of motion here. One is horizontal, one is vertical. Two types of motion. Okay, so you have to realize this, that within this 0.5 seconds, the object has covered a distance of 10 meter horizontally, and it has also fallen a distance of s meter vertically in the same time, because it was occurring simultaneously, horizontal and vertical together, right? Now the question asks you, what is the value of s? When it was falling down, what is the value of s? Now it's easier for us to solve. Again, we take the same equation, ut plus half at squared. What was the initial vertical velocity? Since it's vertically falling down, the vertical velocity initially was 0, because we have not given any vertical velocity. So if this is 0, the entire part becomes 0. Half a is 9.81. We don't need to take minus. Why? Because we have discussed here, it's falling downwards, there is no upward motion, so we take it as plus. Into how much time did it take to fall from here to here? The same as this one. If it takes 0.5 seconds to travel from here to here, it also takes 0.5 seconds to fall the same height from here to here, right? So the time remains the same, which is 0.5, and from using that you can find the value of the vertical displacement of the object. Okay, so remember this from this video, that when an object is moving with a horizontal velocity, throughout the motion the horizontal velocity remains the same. That is, it will cover 20 meter in every 1 second. If it moves for say 3 seconds, it will cover 60 meter horizontally, because this velocity is not going to change. Horizontal velocity remains constant. However, even though you have not applied any vertical velocity, as it falls, the vertical velocity gradually increases. Why does it increase? Because of a resultant force which causes an acceleration in the vertical direction. Okay, as a result, the velocity keeps on increasing vertically, whereas the horizontal velocity always remains constant. So while solving this maths, we took the acceleration 0 when we are finding the time using horizontal distance. So the distance here was horizontal distance, so the acceleration is 0. When we were finding the vertical distance, we didn't take the acceleration 0, we took it as 9.81 into 0.5 square. Sorry, there should be a square here, right? T square, so this should be 0.5 square. Okay, so that's how we can find individual values of the displacement horizontally, vertically, and the time taken. Alright, so I hope that's clear for everyone. Okay, alright.